creating geospatial data. So what you're going to learn in this part, the theory on coordinate transformation, digitizing, manual digitizing, automatic digitizing, and feature generation. So we'll cover this very quickly. So there are two types of data. First one is your tangible map on the left, and then the other side is your virtual map. So one is hard copy, and one is soft copy. Hard copy data. So hard copy data is stable, cheap to produce, does not require hardware, software to use. It's semi-permanent, it's portable, familiar to many users, reusable, but it's not very easy to update. So in general, I mean, if you look at the text part, they said basically in 1980, most GIS data was hard copy. Today, most data is soft copy. In Mongolia, there's still a lot of hard copy. We still use paper a lot, but it will gradually move to the digital. So there are advantages and disadvantages of digital data, okay? So digital data is the advantage, it's usually stable as long as it's maintained and backed up. It's cheap to store now. It's got good information, it's flexible, and it can be easily updated. Disadvantage, not portable without hardware and software. It raises the barrier for users, and the hardware and software may not be easily understood by the users, and the data may be tied to specific systems that depreciate over time, so there's need to continuously update the data into newer hardware and software systems. This used to be true that certain companies like ESRI, Autodesk, people like Intergraph, they had their own formats for data, and so it's very hard to share the data between if you're from one vendor to another vendor, okay? So that was a big disadvantage in 10 years ago, for example. Now, that has changed quite a bit now with free and open source for geospatial. For the OSGeo community, the open source community has changed that paradigm, that model, quite a bit now. But still, some vendors like ESRI will still try to make their software products specialized, even though the data can be shared, by designing some systems internally that only their hardware can use. Nowadays, there are consultants and service providers that will put middleware in there that will allow other people to use that data. So my only advice to the Mongolian people here that work for the government is to try and make sure that when you hire vendors or you select vendors, make sure that you are not trapped into having to use their hardware and software systems. There's no reason today to have that requirement anymore. And you should make sure that you try to use open systems as much as possible. And even the vendor specific, you tell them that even if you want to buy their equipment and their applications, you want them to be able to use open data. Moving along then, what is coordinate transformation? If you look at the picture up there. Yeah, so coordinate transformation is if you were at the drone training, we were talking about the source image. Okay, if you remember, we did control points using GPS. So we're able to get the control points on a map, and you transform the map so that it gets into the right orientation for the coordinates. That's transformation. I call also, the term is georegistration. It's also another term to be used for moving a map into the proper coordinate system. Performing coordinate transformation, so there are many ways to do transformation. So once you've transformed the map, you can use control points, for example. So the control points should provide the highest coordinate accuracy. So remember, I was talking about accuracy. Digital data has accuracy. And accuracy should be at least as good as the desired overall positional accuracy, and should be evenly distributed throughout the area data. You're going to create a map. And this map might be at a certain scale. So when we collect the control points, we need to decide how accurate the precision of the control point is. Can I use a handheld GPS, or do I need to use a survey grade GPS? So do I need, is 1 or 2 meters accuracy okay? Or do I need 1 or 2 centimeter accuracy? Okay, if I say, okay, 1 or 2 meters is good enough for this map that I'm creating, then I can use a Garmin handheld. Okay, if I need 1 or 2 centimeter accuracy, then maybe I need to use RTK survey GPS equipment. I run into this a lot, okay? People that are using survey grade control points for a map that doesn't need that accuracy. This happens quite often. People will use RTK for a map that doesn't need RTK. Because the final map product, printed product, you cannot measure 1 or 2 centimeters, you can only measure 1 or 2 meters on the map. So you waste a lot of time doing RTK for a map that doesn't have that accuracy. Control points, so again, there's 2 kinds of control points. You can go out and collect points if there is no other reference, or you could use an existing map, which already you know is registered and has coordinates that you can match the features from. So digitizing, you used to do a lot more digitizing of maps in the past than you do now. Nowadays there's less and less need for digitizing of paper maps. But you will still create vector data using orthophoto imagery, so you would still be digitizing. So a node and vertex. So we go to points, lines, and a vertex is just where you click the mouse. Okay, so the 2 definitions in digitizing. A node is the start or end of a line, and a vertex is a point inside a line. Example, you start a line, this first point is called a node. The next point you digitize is a vertex. So node, vertex, 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 vertex. End of this line is a node again. But here, this is node to node. This is 1 segment. This can traverse 1, 2, 3, 4, 5 segments, this line. So you say, why do we care? You care because later on is what is called topology in GIS analysis. So nodes and vertices are important. But if you're not worried about topology and GIS analysis, point is a point. But node, vertex, just remember that for now. So coming back to this, the other 2 things you'll know in topology, GIS topology, it's very common, overshoot and undershoot. And we will deal with this when we try to build polygons and we try to clip polygons. You need topology, otherwise they won't work. But the most common thing is, an undershoot is when you digitize and you don't land on the line. You don't snap to the node on the line. Okay, so this is undershot because it's not touching the line. And overshoot is you cross the line. It's just worth noting. It's important if you're doing digitization and want to build polygons. So there are 2 kinds of digitizing. There's manual, you physically heads-up digitizing on the screen. So the advantage is you have human, not artificial intelligence doing the digitizing. So theoretically, you have better interpretation. The negative side is accuracy and overshoots and undershoots. Different operators have different standards, and some are more sloppy than others. So you could have bad work. Yeah. So automatic digitization. Automatic digitization is when you use software to automatically convert raster to vector. So for example, you have a paper map of contours and you want to automatically, instead of sitting there and digitizing many lines, you have a software that would go and automatically create vector lines from the raster image. These days, there is less need of this kind. It used to be, we did a lot of this work for automatic converting paper contour maps to vector. An example would be back 10, 15 years ago in Canada, we had the national topographic maps, 1 to 50,000 paper maps. All the 1 to 50,000 topographic maps for the whole country. But these were hard copy. And the government had not the paper side, but they had the film developed of these maps. So when Natural Resource Canada wanted to create digital topographic maps for the whole country to make it available to everybody, so they used automatic digitization of the hard copy maps so that all the contours were created into vectors, converted into vectors. Okay, so today, I don't know where the website is, but you can go into the Canadian government website and download PDFs of the paper copy, or you can download the shapefiles for the contours. That was automatically digitized. You know, the positive thing is it's if you write software and you have actually a good paper map, the results usually are very good and consistent. The bad side is if the map was not very good or not very good quality, then you have a lot of mistakes that the computer would do, and you have to fix them. What is feature generalization? A feature is an object in the real world that we may want to represent on a map, but there's too much detail in the real object, so we would generalize it in a map. So an example, for example, we want to create building footprints, houses in a map. We want to put on a map from the ortho photo that we have from the drone. We want to do the building footprints in the center line of the road. So this would be a typical urban map. So in terms of generalization, there is 5 things. There's what's called fused, simplification, displaced, omitted, and exaggerated. So fused means originally each building is separated uniquely. Yeah? So fused means after you simplify, these 2 houses became 1 house. In terms of simplification, this happens quite a lot in different maps. If you can see that this shape, for example, this building footprint is quite complicated, a lot of jacks, and in the map you simplify it into just rectangles. And displaced. So displaced is the original data. This is where the house actually is. And when you displace it, you just put it closer to the road. So the map does not show the real position of the house, the center of the house. And then omitted is if you leave out the building, the other buildings that are there, then they're missing. And then finally, what we call exaggerated. So for example, the road center line is made thicker. The broad directives for generalization. You need to make sure what is the purpose of the map, very important, the scale that you're dealing with, and you're going to be consistent.